Mamta Modern School, H Block, Vikaspuri. The chemistry project on climate change in Delhi and Sikkim, presented by the student of class 12 science under the mentorship of our chemistry teacher, Mr. Digvijaynath Divedi. The topic of our project is the comparative study of climate change between Delhi and Sikkim. The first question that arises in our mind is, what is climate change? As you can see, climate change is the global phenomenon of the climate transformation characterized by changes in the usual climate of the planet regarding temperature, precipitation and wind that are especially caused by human activities. The causes of climate change: strength of the sun, changes in Earth's orbit, changes in the orientation of the Earth's axis of rotation, quantity of greenhouse gases in the atmosphere, and carbon dioxide content of the ocean. Delhi. Delhi is the capital city of India and is regarded as the heart of the nation. The city is popular for its enriched culture and heritage. The city hosts some famous historical monuments and is developing with the passing of time. Sikkim. Sikkim, India's 22nd state, shares border with Nepal, China, Tibet, Bhutan, and West Bengal. The world's third highest peak, Mount Kanchenjunga, is located in the northwestern part of the state. Sikkim has more than 10 peaks that reach a height of 6,000 meters or more. The key features of Delhi and Sikkim are shown in the presented slide. First, we have Sikkim. Limbu, Lepcha, and Bhutia are their close relatives. Kiranti and Tibetans live in Nepal, Tibet, Bhutan, and neighboring states of India. The Lepchas, earliest ethnic group, settled in Sikkim by 13th century from before Tibetan Bhutias arrived. The Bhutias immigrant to Sikkim claimed descent from a common ancestor, a Khampa chief named Xiia, and were divided into 14 main families. New Delhi. New Delhi, the capital and the third largest city of India, is a fusion of the ancient and the modern. Represents a picture rich with culture, architecture, and human diversity. Profound in history, monuments, museums, galleries, gardens, and exotic shows. Places like Connaught Place, Janpat, Sarojini Nagar, Karol Bagh, Red Fort, Delhi Hat are known to throw a long-lasting spell on its tourists.
The climate of New Delhi. New Delhi, the capital of India, has a humid subtropical climate that is classified as CWA under the Köppen climatic classification, bordered by a hot semi-arid climate classified as BSH under the Köppen climate classification. This causes a huge difference in the temperature and rainfall reading between summer and winter. Influenced by the monsoon winds, the climate is characterized by long scorching and relatively rainy summers and short, mildly warm and dry winters.
Climate of Sikkim. Sikkim's geographical location, with its altitudinal variations, allow it to have a tropical, temperate, and alpine climate condition within its small area of 7,096 kilometers. Temperature conditions vary from subtropical in the southern lower parts of cold desert in the snowy north. It is also the most humid region in the whole range of the Himalayas because of its proximity to the Bay of Bengal and direct exposure to the southern monsoon. Rainfall is heavy and well distributed during the months from May to early October. July is the wettest month in most of the places. The intensity of rainfall during southwest monsoon season decreases from south to north, while the distribution of winter rainfall is the opposite order. The highest annual rainfall for the individual station may exceed 5,000 mm, and average number of rainy days are more at Thangku in North Sikkim to 18 at Gangtok in East Sikkim. Comparative study of Delhi and Sikkim's climate. The hottest season is in March, April, May, June, July, August. The month of June, July, August, and September have high chance of precipitation. In Sikkim, the warmest month is August with an average maximum temperature of 19 degrees Celsius. The coldest month is January with an average maximum temperature of 9 degrees Celsius. In Delhi, the interior location far from the sea and hemmed by mountains creates a dry continental climate in a largely humid subtropical region. Climate in Delhi is characterized by extreme differences in summer and winter temperatures. Winters are chilly at night but pleasant during the daytime. In Sikkim, the northern cold desert of Sikkim is under snow for most of the year. It means that most of the inhabited regions of Sikkim barely experience a temperature in excess of 28 degrees. Even during the peak summer season, with its great diversity in landform, even the small 7,000 km area of Sikkim experiences tropical temperate and alpine climate. Steps taken by government regarding climate change in Delhi. Introduce a carbon tax. Capturing carbon and planting trees could help slow and eventually reverse global warming trends. A carbon tax could be used to deter more emissions, and some of the cash could then put into important solution on the other side of the coin, such as capturing carbon and planting trees. Solar roadways. India should also take advantage of its vast of worlds of roads across the country and the sun that beats down on them and turn them into energy, creating solar superhighways. The idea of solar panel road is to replace traditional asphalt roads with glass-based solar panels that you can drive on, in a bid of turn roads into sources of renewable energy. Develop energy storage. This includes thermal storage, grid battery storage, compressed air gas, vehicles to grid, pumped hydro fuel cells or other hydrogen storage, flywheels, superconducting magnets and supercapacitors. Renewable innovative financing solutions. Provide innovative financing to instill more confidence from potential investors and decrease the cost of financing for renewable energy projects. Steps taken by government regarding climate change in Sikkim. Developing energy storage. This includes thermal storage, grid battery storage, compressed air gas vehicles to grid home pumped hydro fuel cells or other hydrogen storage. Exponentially increase the development of renewable energy. Aggressively expand large-scale deployment of both centralized and distributed renewable energy, including solar, wind, hydro, biomass, and geothermal, to ease the strain on the present transmission and distribution system and to allow more of off-grid population to be reached. Provide incentives to kickstart renewable energy programs for massive solar rooftops over 100 million and with home energy storage battery. Planting more and more trees. Trees act as an helping hand in improving the harsh climate conditions as they absorb almost all the carbon dioxide, which is in the biggest factor of unfavorable climate in it, and provide oxygen, and it also act as the shelter for some animals and provide food to them and protect them from rain. The roots of trees also prevent soil erosion, which is also a factor of climate being harsh and polluted. There are already large number of trees in Sikkim, but due to rapid increase in its use for human needs, more trees needs to be planted. So by avoiding deforestation and planting trees, climate change can be removed. The conclusion derived from this project is climate change is one of the major environmental threats facing the world. Studies have shown that India's subcontinent is likely to experience a warming of over 3 to 5 degrees Celsius increased flood and drought frequency and intensity. However, climate is one of the most important determinants of vegetation patterns globally, and thus climate change can significantly alter the distribution, structure, and ecology of forests. Forest type of distribution, carbon stocks or emissions, and climate change are interlinked processes. Deforestation and land degradation contributes to about 20% of global carbon dioxide emissions, and forest sector provide a large opportunity to mitigate climate change, particularly through the REDD Plus mechanism. Climate variables like precipitation and temperature were taken into consideration to understand the past and current trends. The drought and flood data were also accessed to understand the recent trends. But keeping in mind the various model limitations, there is a need for multiple climate scenarios and vegetation model based assessment of climate change impacts at decentralized levels. Critical evaluation of the current national as well as state policies, programs, and capacity of execution are required that will help in increasing resilience of forests.